Hello, class. Our goal today is to cover how to approach it when someone gives you a question of this sort, where they've given you a multiple choice question, or on the homework, sometimes it's a matching question, where they've asked you to find an integral, and then they give you a bunch of options. So I want to note right off the bat, we don't know the integral of natural log of x, and we don't currently have any way of figuring out the integral of natural log of x. So if we were not given these options like we were here, we would be sort of stuck. We wouldn't have any idea. You'd basically just have to guess all day long until you guessed correctly which thing was the integral of natural log of x. But given that we're 3/4 of the way through a year of talking about derivatives, the thing we're very good at doing is taking derivatives. And so instead of taking the antiderivative of natural log of x, we can take the derivative of each of these options until we find one of these whose derivative is actually natural log of x. And once we've done that, then we're in good shape. And of course, as we get smarter at doing this, you might be able to guess more quickly which one it is. So you certainly don't have to start at A and work your way down, but you can if you want. Okay, so let's start. And so all I'm trying to do here is I'm trying to figure out which of these 5 options that I've given you has derivative natural log of x. Okay, so I can look at A first. That'll be the derivative of 1 over x. Thinking of that as x to the minus 1, that is minus 1 over x squared. So that is not natural log of x, so that's not the answer. So we move on to B. So we go to take the derivative of x squared times natural log of x minus x squared. Note, I'm not even bothering to write the plus c over on this page because I know as soon as I take the derivative of the plus c, I'm going to get 0. So I'm only copying the stuff that's not the c. Okay, so here I'm going to have to do the product rule. So I'm going to get 2x times the natural log of x plus x squared times 1 over x minus 2x. So this is 2x natural log of x plus x minus 2x. So this is 2x natural log of x minus x. Well, maybe close in that it has a natural log in it, but that's not natural log of x. So we can cross that one out. Okay, so C, we're given, hey, let's guess natural log of x minus x. Okay, so if I take that derivative, it's going to be 1 over x minus 1, which is going to be equal to, I guess, 1 minus x over x. That one doesn't even have a natural log in it, so it's probably not that one. Okay, so here, okay, and I'll note, of course, we're unlucky, and the one is going to be one of the very end ones. But actually, if I have faith that I've taken these derivatives right, as soon as I take this derivative, I'm going to know the answer, because either this is going to be the answer, in which case I'm done, or it's not going to be the answer, in which case, like all these questions with the graphs and the homework packet and whatever, I'll have eliminated 4 of the 5 answers. I'll know the other one has to be it. So one way or the other, we're going to be done after this one. Okay, so here I take the derivative with the product rule. So this is 1 times the natural log of x plus x times 1 over x plus 1. And so this looks good because there's a natural log of x here. Plus 1 plus 1. So this is actually the natural log of x plus 2. Well, that one was super close, but the natural log of x plus 2 is not the same as the natural log of x. So it's not that one. So that means really it must be this one. But just for completeness sake, let's go ahead and do it just to make sure you really believe that if you take the derivative of this thing, you really get natural log of x. So let's make sure I did not lie to you and give you no options that worked out. So let's take the derivative x times natural log of x minus x. Okay, so that's going to be 1 times the natural log of x plus x times 1 over x minus 1, which is the natural log of x plus 1 minus 1, which is the natural log of x. Hooray! Okay, and so remember, again, the only thing we were looking for this whole time when someone asked, hey, what's the integral of natural log of x dx? All that's asking is, what's a function whose derivative is natural log of x? And so after trying all 4 of these options that didn't work, this one did. So this is the integral of natural log of x. Okay. Now, again, I want to point out, it would have taken you a really long time if there had not been choices here for you to guess through functions until you eventually guessed the function x times the natural log of x minus x. Okay. And now you're smart. I'm confident you would have eventually gotten there if you really had to try all the functions. But there's no coherent strategy yet for us to get from just the function natural log of x to this specific function. In fact, actually, this is an integral that it will take you until taking the beginning of Calc 2 for us to know how to do. We'll talk about how to do some of these other integrals that I'm going to do in this thing later in this semester. But for this one, if you want to be able to sort of really go from just there to this answer without someone giving you options, you'll have to use something called integration by parts that we're not going to go over this semester. Okay. But let's go here. Okay. I'm going to do one more after this, but I'd encourage you, if you feel like you're following along, go ahead and pause the video now and try and do this one before we do it together. Okay, so now I'm going to do it, but pause the video if you haven't yet, really, and try this, because just make sure you're comfortable with what we're doing here. Okay. Now, as I said before, there's no reason you have to do it top to bottom. So I know that Tommy fellow, and I know he's always going to put it at the bottom, so I'm going to be clever this time, and I'm going to start with the last option. And I'm going to take the derivative of that and see what happens. Because maybe, if this just works out, then maybe I'll get away with only trying one thing. Because once I've found the answer, I definitely don't have to take the derivatives of the other things. Okay, so this is going to require... Okay, and now here's where you have to be extra careful, because now we're taking the derivatives of sine and cosine again. And remember, the SIGN sort of sign on those derivatives is flipped from the integrals of sine and cosine that we have been taking. So use extra caution when doing this. Okay, but this is going to be 1 times cosine of x plus x times minus sine of x plus cosine of x. Okay, so it looks to me like the thing I got here was minus x times sine of x plus 2 cosine of x. Okay. Darn it, he guessed I was going to do that and made it not the last one this time. So maybe he outthought me. So let's try the first one. Maybe he thought, oh, I know he's going to try the last one first, so let's go up and let's put it at first, so let's try that one. So if I take the derivative here of the first one, will be x times cosine of x plus cosine of x. Okay, and this derivative will be 1 times cosine of x plus x times minus sine of x plus minus sine of x. Okay. That's not even close, so it wasn't that one either. Okay, now I'm really uncertain. I've tried A and D. I don't know which one I'm feeling this time. Let's try C, I guess. Again, we're down to there only being 2 of them, so whichever one I try, either it's going to work and I'm done, or it's not going to work and I'm also going to be done because I'm going to know it's the other one. Okay, so let's take the derivative of x times sine of x plus cosine of x. Okay, and so the product rule is going to tell me 1 times the sine of x plus x times the cosine of x plus minus sine of x. Hey, would you look at that? There's a minus sine of x and a plus sine of x, so those cancel. And so I'm left exactly with x times cosine of x. Okay, and note, again, that's all I need to know that I have correctly found the integral of x times cosine of x. I found a function which, when I take its derivative, I get x times cosine of x. Okay, and so that means the correct answer here is C. Okay. Let's do one more of these. Okay, well, both previous questions have ended up with something with like an x times something, so I sort of like the look of A here. For maybe this is going to be the integral of tangent. So let's start with A. Maybe I'll get lucky. So the derivative of x times tangent of x minus secant of x is, okay, so it's 1 times tangent of x plus x times secant squared of x minus secant of x tangent of x. That's supposed to be tangent of x over there. That I just sort of wrote all squished up. That's a little less squished up. Well, that didn't work, because that's not tangent of x. It's got a tangent of x in it, but it's not tangent of x. Okay. Well, I guess I no longer have faith in my ability to guess which one of these answers it's going to be. So let's just try B and see if it works out. Okay, so here we need to take the derivative of the natural log of the secant of x. So here, in order to take this derivative, remember I'm going to need the chain rule because I've composed 2 functions here. So my f of x here is a natural log of x. My g of x here is a secant of x. F prime of x is 1 over x. My g prime of x here is secant of x tangent of x. Okay, and so this derivative, remember, by the chain rule, is now going to be f prime of g, so that's 1 over x of secant of x, so that's 1 over secant of x, times g prime, so times secant of x tangent of x. But, would you look at that, I have a 1 over secant of x times a secant of x. So this works out to be tangent of x. And that's the thing I wanted. So that means the integral of tangent is really the natural log of the secant of x plus c. Okay. Now, again, to emphasize what I'm showing you how to do these questions, but I'm also showing you that you really can't guess the integral of a lot of these functions just by playing around. Because whoever would have thought, why on earth would there be, maybe the secant's not surprising, but why on earth would there be a natural log involved in the integral of tangent? Why would the integral of x times cosine of x be something like this, where we had to multiply stuff out? Okay. So there's going to be lots of functions that we are very happy to work with, but whose integral we don't know. So, for example, we don't know what, say, the integral of secant of x is. Okay. And believe me, if you guess for a really long time, you're going to have to guess for a really, really long time before you can guess this. Okay. But randomly, we do know what the integral of secant squared of x is. Okay. And why is that? It's because one of our derivative formulas happens to be that the derivative of tangent of x is secant squared of x. So we know that one. Okay. But then secant cubed, we don't know that one either. Or if someone gives you something like the integral of square root of 1 minus x squared, well, I have no idea what this is. And none of my rules that I've showed you so far are helpful. But if someone had just happened to ask, hey, what's the integral of 1 over the square root of 1 minus x squared instead, this we do happen to know because this just happens to be exactly our formula for the derivative of arcsine. And so the moral of the story here is that out of all the functions, we randomly know some antiderivatives. We randomly know how to integrate some of them, and plenty of others we don't. So right now, there are a bunch of isolated random functions we know how to integrate, and a lot of other functions that we just have no idea how to go about integrating. And of course, the more we talk about this, the more we'll figure out how to integrate functions like this and so on. All right. Just for the record, I don't expect you to memorize or have on your worksheet the integrals of any of the random ones from this. If you need them, I promise we'll do them in a more honest way later, but I definitely do expect you to be able to match integrals with the corresponding function by doing this sort of, well, I can just check the derivative sort of idea. All right. We'll wrap up there for now. In the next video, we're going to talk about how to look at graphs of functions and what the graphs of antiderivatives look like. But until next time, be well.